So let's use some equivalent ratios to solve some proportional relationship problems. This first one says the relationship between the number of hours a plumber works and the total work fee she charges is proportional. So one thing that's telling us right there is that we know that there is going to be some constant multiplier, that the number of hours she works times some number, I'll put K, is equal to the number of dollars she charges. So our job is going to be to figure out what that is. And one of our best tools for figuring that out is going to be making a table. So before I've even read the problem and seen the information that we're given, I'm going to set this up where I'm going to put hours in the left-hand column and her charge in the right-hand column. So now I'm going to keep reading. It says that her fee for 5 hours of work is $350. So I'm going to go ahead and set that up in our table. Now, the reason why I put hours on the left and dollars on the right is that hours is our independent variable and the money is the dependent variable. In other words, the amount of money that she charges depends on how many hours she works. How many hours she works is the thing that she controls, which is what makes it the independent variable. So they're looking for other combinations of values for her work hours and the fee that she charges. And before I look at any of those answers, what I'm going to do is I'm going to figure out what my multiplier is. So to do that, I want to create a row in the table that is going to have my unit rate or my constant proportionality. In other words, it's telling me what my multiplier is. So we know that a unit rate is when one of the values is 1. So I want to figure out how much money does she charge when she only works 1 hour. I can figure that out by seeing that I can go from 5 to 1 by dividing by 5. So to keep my ratio equivalent, I'm going to divide by 5 on this side of the table as well, which gives me that for 1 hour, she works $70. This tells me that my multiplier in my table is going to be 70 because I know for certain that 1 times 70 is 70, and I can check that here. 5 times 70 is 350. So now to figure out any of my other values in my table, all I need to do is see if they follow that exact same rule. So I'm going to go ahead and extend our table and add some of them in. So it says 3 hours and $270, 3.5 hours and $245, 6 hours and $420, 7.25 hours versus $507.50, and 8 hours and $490. So I'm going to see if any of those rows give me my same multiplier. So what I'm going to do in every single one of these is going to be multiply my number of hours times 70 and see if it's true. Now, when I do 3 times 70, I get 210. So because it didn't give me the value that it told me I should expect, I know that that is not equivalent. 3 hours and $210 would be. So I'm going to try that with my next row as well. 3.5 times 70 gives me 245. That means that this row works, and that means that answer is good. Continuing on, 6 times 70 is 420. That row is good. And 7.25 times 70 does give me $507.50 if I were doing this in a calculator. Now, I already know that this told me to choose 3 answers. So since I have 3 answers, I already know that E is going to be wrong. But if we go ahead and check it and do 8 times 70, it gives me 560. In other words, not the answer that it gave me here. So I know that that value is incorrect. Let's look at one more problem. So here it says Sage's spaceship traveled 588 kilometers in 60 seconds. Now I'm going to do the exact same thing and set up a table. I'm going to put seconds on the left and kilometers on the right. So I'm going to put 60 seconds with 588 kilometers. Again, I put seconds on the left and kilometers on the right because the distance that you travel depends on how long you're traveling. So seconds is my independent variable, kilometers is my dependent variable. And just as before, I'm going to try to figure out my unit rate. In other words, how many kilometers does the spaceship travel in 1 second? I can do that because I know that 60 divided by 60 is 1. So I'm going to divide by 60 over here. 588 divided by 60 gives me 9 8/10. So that's what I know my multiplier is. In other words, that's my constant proportionality. So I just need to see, do those other values give me that exact same constant proportionality that I'm expecting? So just as before, I'm going to go ahead and plug those values into my table before I see if they work. So 45 seconds with 441 kilometers, 25 seconds with 215 kilometers, and 110 seconds with 649 kilometers. So now I'm going to go ahead and check that. 45 times 9 8/10 is 441. That means this row works. That means that spaceship is traveling at the exact same speed as Sage is. Looking at the next one, 25 times 9 8/10 is 245. That tells me that this answer is not correct because it's not the same. So that means that that spaceship is traveling at a different speed. And for my last one, 110 times 9 8/10, let's see. That gives me 1078. Definitely not correct over here. So that means that this spaceship is traveling at a different speed because it has a different value that is taking us across the table. 9 8/10 didn't work for us here.